So we're going to continue on with the matrix multiplication. So number 3, you have 3 matrices, and we want to find AB plus BC. So we're going to go to our calculators. We're going to do second, x1 again, so second matrix, over to edit. Now our first matrix, well, all of these matrices are actually all going to be 2 by 2s. So you're going to enter that in, and then make sure to enter in your numbers. So this is the easiest part. Great, so I got 1 in, and do the others as well. So how about you pause the video here and enter in those matrices and try to see if you get the correct answer, the same answer that I get, okay? So you're going to do matrix B, and then you're also going to be doing matrix C. You're going to have that edited as well. Okay, so pause here. And you should end up, when you do it in your calculator, multiplying AB plus BC, -2, 0, 24, and 14. Alright, the next example, verify the above 2 examples, I should say below, using a calculator. Then use a calculator to simplify the following expression. So, what we did here, AB plus BC, it's kind of like number 2, right? BA plus BC. So we're trying to determine whether or not these B times A plus C and BA plus BC, whether those are the same. Okay, so pause the video here, try to enter this into your calculator using the matrices, and try to enter this into your calculator as well and see what you get. So when you do that, you see that, oops, I have a typo, this should say -16, that they are indeed the same matrix that you end up with. So this tells us that the distributive property for matrices does indeed work, and we can indeed distribute this B towards both of the other matrices. Alright, so moving on, we finished with matrix multiplication. Now we're going to talk about the determinant of a matrix. So the determinant is a very important part, a very important number, I guess, of a matrix, okay? So the determinant of, let's say we have a 2 by 2 matrix, A, B, C, D. The determinant is, we take A times D and multiply that by BC. So a lot of people, whenever they're thinking about determinants, like to draw arrows. Oof, that came out really thick. So it's that minus BC, okay? So if it helps you to draw the arrow, go ahead and do that. But you take the A, multiply it by the D, and subtract it from, and subtract BC. Okay. So here, let's try finding the determinant. So here we're going to take -6, multiply it by -7. So that's going to be 42, and subtracting 2. So 40. And what's the determinant of number 2? Well, we get 1/2 times 8 minus 4 times -2, -8 is 12. Great. Let's say we have a 3 by 3 matrix, advancing it a little bit. What we do for a 3 by 3 matrix is we kind of look at it as a few separate matrices. So I'm going to get out a pen for this. So first thing we do, we take A and we then kind of look at the matrix of E, F, H, I. And we find the determinant of this matrix. So you take A, you eliminate the column that it's in, you eliminate the row it's in, and then you're left with a 2 by 2 matrix, and you take the determinant of that and multiply it times A. Okay, so that's why we have A times EI minus FH right here. So that's the determinant. Now the next one, so you already did EI or A. Now what happens if we take B? If we take B and we eliminate the row and the column, then we're going to take the determinant of the remaining numbers. So D times I, right here, and subtract F and G. Okay. And then, multiply that times B, of course. And then lastly, whoops, this should say G. It was a typo in your guys' notes. So make sure you fix that. Let's say we take C, alright? We're going to take C, eliminate that row, eliminate that column. We have DH minus EG. And here you have it. So, let's try finding the determinants. Find these determinants by either doing it the long way, like what we did up here, or we can also use our calculator. So I'll show you how to do that. Let's pull up your calculator again. we're gonna do number 1, okay? So we're gonna plug in that matrix. So second matrix, over to edit. I'm gonna do this as number 3, or C, okay? This is a 3 by 3 matrix. So plug in your numbers. Okay, you have your 3 by 3. Now, much similar to, you know, how we use stat calc, we're going to now do matrix and do math. And number 1 is the determinant. So you'll press enter, determinant, and then you want it to be matrix, whichever matrix you plugged in. So I chose matrix C, so I'm going to do number 3C and spit it out. -89. Indeed. So try entering in the next 2 matrices into your calculator and getting the determinant. So pause the video and try that now. So you should have gotten -36 and -25. Alright, so now that we've gone over determinant, we just have a little bit left to do. First thing is that we want to identify or recall what the identity matrices are. So identity matrices are 1, 0, 0, 1 for a 2 by 2, and 1, 0, 0, 0, 1, 0, 0, 0, 1. So 1's all along the diagonal. So why are these called the identity matrices? Well, let's say we were to plug these 2 matrices into our calculator, which you can do if you would like to see it, but I'm just kind of going to skip over it. But you should probably check it, because you shouldn't believe everything I tell you, right, kiddos? So you have a matrix and you multiply it by the identity matrix. What you end up getting is you end up getting the same matrix. Okay, so if you were to do that, again, plugging into your own calculator and trying it, you get the same matrix at the end. Now, here's an important definition, okay? So you're gonna be using this a lot. If 2 matrices are inverses, then A times B is equal to the identity matrix, and B times A is equal to the identity matrix as well. So we can prove that these 2 are inverses by using our graphing calculator. So let's plug in these 2 matrices into our calculator. We're going to stick with the 2 by 2, so we got 3, -1, -5, and 2. Second matrix, over to edit, number 2, 2 by 2, good, 2, 1, 5, 3. Alright, so let's test it out. So let's do second matrix. We want A times B. Ooh, that's what we get, the identity matrix. Okay, now let's try the reverse. So let's do B times A. Ooh, we get the identity matrix again. Okay, so that means that they are inverses. Now the way that we notate an inverse matrix is as A, or whatever that matrix is. Let's say we're, looking at the inverse of B, or the inverse of C. It's that matrix to the -1, basically. Okay? That's how we denote an inverse. So let's now learn how to find the inverse by hand. So given that A is equal to A, B, C, D, then the inverse is the following. So you take 1 over the absolute value of A, which this notation is the determinant, okay? So right here, that's your determinant. In case you forgot. I think I might have missed that before when I went over determinant to talk about that notation. Ooh, that's determinant of A. And then you switch around the numbers that you have. So you switch your A and your D, and then you make your B and your C negative. So switch A and D, B and C become negative. Okay, so let's try it. So given A equals 3, 4, 1, 2, find A -1. So first of all, where did this 1/2 come from? Well, this 1/2 came from the determinant. So 1 over the determinant of A, the absolute value of A, right, is 3 times 2. 6 minus 4 is 2. That's where this 2 came from. Then we switched the A and D. So 3 and 2 became 2 and 3, and made 1 and 4 negative, right? And then you just multiply. So 1/2 times 2, 1, 1/2 times -1, -1/2, 1/2 times -4, -2, 1/2 times 3, 3/2. Okay? Great. Now, let's go on. So prove that A and the matrix computed for A inverse are truly inverses. So what you would do is you would plug in this as one matrix and plug in this as one matrix and multiply them. And to check, you want to make sure that they are inverses, that they give you the identity matrix. Okay? Example 2. So here, 6, 1, -8, -2. Find A1, A inverse, right? And then show that that is truly the inverse. So how did I get this matrix right here? I want you to see if you can get that, okay? So you're going to find the determinant of A, 6 times -2 minus 1 times -8, right? That goes on the outside. Then what do you multiply that? Well, you switch your A and your D, and you make your B and C negative. Okay, so try that out and see if you get the same matrix that I got. And lastly, example 3. Given A is equal to this matrix, 6, 3, -4, -2, find A inverse. Well, what happens with this one is that your determinant is equal to 0. When you have a determinant of 0, if we go back up to our definition of how to find the inverse, that would mean that we're dividing by 0, which we cannot do. So therefore, example 3, this has no inverse. Okay? All right. Last thing we're going to do today is solving a matrix equation. So let's say that I have a matrix A and I'm multiplying that by some x, and I want to solve for that x. And I have it set equal to some matrix. Well, we can set this up and just call this matrix A and this matrix B. So we set it up, AX is equal to B. I can't just divide matrices, okay? We cannot divide matrices. However, what we can do is multiply by inverse matrices. So I'm not going to divide here by A, all right? I'm not going to divide out by A in order to get X alone. Instead, what I have to do, kind of like how division is multiplying by the reciprocal, that's kind of similar to what we're doing in a way. Is we don't want to divide, but we are going to multiply by the inverse. So A inverse times AX, we can multiply, or set that equal to A inverse times B, right? So then X, A inverse times A, that's the identity matrix, so it's essentially like multiplying by 1. So X is equal to A inverse times B. So now what I want you to try is to find what is A inverse here, which you've been doing, so you've been practicing that. Find A inverse. Plug that into your calculator, plug B into your calculator, and solve. So pause the video here and try that. So you should have gotten negative this matrix right here. Alright, so now we're moving on to the you try examples. So there's going to be a few different examples, which I'm not going to go through fully. This next one, I think that you guys can try on your own, so try that one. Here's your answer, so you can check your answer when you're done. But I do want to look at number 1 real quick. Okay. And then this will help you to do the rest of them. So we can use inverse matrices to solve systems of equations, like what I was talking about at the beginning. So what we can do here is we can take the coefficients of our x, y, and z and plug those in as entries in our matrix. So, for example, this first line, 1, 1, 1 times x, y, z is equal to 10. Next one, 5 times -1 and 0 z's, right, x, y, z is equal to 1. 3, 4, 1 times x, y, z, right, is equal to 8. So we can set this up just like this, and then we can go through the problem using the inverse matrix, right? So you're going to find the inverse matrix here, and then you'll be able to solve for x, y, z, and you'll get 3 outputs. So I want you to try these problems, okay? I'm going to end the video here, but I want you to try these problems and bring your questions with you to class, and we'll be able to go over those together, okay? So try these problems, finish those up for homework, and then you'll have the extra practice as well to try for homework. Again, answer key for this is posted on Blackboard, so you'll be able to check. And again, bring any of your questions to class with you. Thanks for watching.